as well. Now it's my great pleasure to welcome J.B. Straubel, founder and CEO of Redwood Materials. Prior to Redwood, he was co-founder of Tesla and spent 15 years there. Imagine that, 15 years as the CTO of Tesla. Please welcome J.B. to Climate One. Welcome, JB. So you've been building electric cars since before you were old enough to drive. What was your first one, and how did it go?
Well, my first electric car was actually a golf cart, I suppose, if we go way back. It wasn't even a car formally, but yeah, that was when I was maybe about 12 or 13, I think.
And then you put that together, and then as an undergraduate at Stanford, you kind of learned about climate. You know, I think you've always been interested in those things, but what prompted you to dedicate your life to focusing on climate solutions?
Well, for me, it was probably a passion for the technology and the engineering first. You know, that's kind of what drew me into climate and sustainability. You know, I had a lot of friends in college that were hardcore environmentalists and even activists, and I didn't totally understand where they were coming from initially, but I think I've kind of migrated to really see that side of things. And initially for me it was just a love for the technology and feeling like it was the right way to engineer systems, where you didn't have sort of some open-ended waste or some constrained material that would eventually run out. It was very elegant.
Right, so there's many different pathways people come through: technology or a connection to the earth or perhaps economics opportunity. So how have you come to realize your environmental friends, like the urgency that they're feeling or they're conveying?
Well, I think it's a combination of watching some of the effects of the basically the cumulative effects of what we're doing, seeing the trajectory and how difficult it is to actually change some of these industrial systems. To me that really resonates, and it sort of brings a sense of urgency to this whole problem, which is we can't just sort of wake up one day and flip a switch and decide, oh, okay, yeah, we really should stop burning fossil fuels. Let's do that today. It's a very pervasive, very challenging problem, and touches so many parts of our lives that we need to prepare and really engineer toward a solution way ahead of time.
Right. Without that scientific or urgency, business will go at the rate that's comfortable for business, which is not fast enough. Tesla's first production model, the Roadster, used about 6,800 batteries, essentially laptop batteries strung together.
6831, actually.
6831, yes. My producer wrote that. I rounded it up, but yeah, that's 6831.
Still remember that number.
And looking back now, how crazy does that sound?
I mean, it in hindsight, it was...
or genius, maybe.
I don't know about genius. Many people said it was nuts at the time. These were laptop batteries, basically, way back then. They were, slightly tuned and improved laptop batteries, but stringing together thousands of those at the time when, laptops were catching fire in airports and causing other problems.
Yeah, and cell phones too, yeah.
And cell phones, it was... many people were skeptical, and they had some data to be skeptical. But in the end, it turned out to be a really quite robust solution. And as far as I know, there's never been a Roadster fire in the entire history of that small fleet of cars anyway.
Right. And the industry, you were mocked initially, and there's kind of an interesting narrative of how people talked about the company, particularly people in the industry. So tell us about how the auto incumbents, the giants, kind of shifted their narrative of Tesla from the Roadster days to today, because it's an interesting kind of narrative.
It was fascinating to watch. It was kind of the innovator's dilemma played out, in live feed. But in the beginning, as you said, we were completely dismissed, almost mocked if there was any opinion whatsoever. The Roadster was impractical, it was unsafe, it would never work. I was amazed at how many people thought we were outright lying about, we'd say, okay, it's going to go 200 and, some miles, 250 miles, and they'd say, that's a lie. I'm like, well, no, it's not. We've engineered it. It's going to do it. We'll build it and show it. But that was interesting in the very beginning. It was kind of mockery, dismissal, and that evolved over time. But there was always this sense of
Then came the Model S, and you were like like a rich boy's plaything.
Yep. I mean, that suddenly the Model S, was 10 times the volume or more. It won Motor Trend Car of the Year. It was this impeccable safety record, had obvious data really supporting it, but still there were a lot of reasons why that couldn't change the industry and why
You were going to be a niche. Like, oh, that's nice. Yeah, you've graduated from this, but you'll be a niche.
it's not a car for everyone. It can't it doesn't have enough range, or what about charging, or what about X, Y, or Z. So it was interesting to me. It was kind of a lesson of really how powerful momentum and even maybe denial could be, for whole industries that had so much, going in their direction.
And what I remember is like, yeah, but you can't scale. It's one thing to make, 50,000 cars a year, which, not that long ago was what Tesla was making, but making 500,000, that's a whole different game. We've been doing this for 100 years. We know how to scale manufacturing. And Tesla had some challenges.
Yeah, they were almost right.
Yeah, right? There were a couple of near-death experiences there, and the build quality wasn't great sometimes. But then you moved forward.
Well, truly, scale is enormously difficult, and that is another, I think, underappreciated challenge. If I kind of zoom out on the history of Tesla, getting the technology right was a relatively small percent of the problem. It took a small team and a small amount of resources, and then getting scale correct and doing that profitably was enormously difficult. It took 1,000 times more resources and people.
And did you think that the GMs and Toyotas of the world would respond faster, would change faster to what you were doing?
Oh, absolutely. We were almost maybe idealistic internally, and we kind of thought, oh, okay, we've really shown them now, and this car will, move the whole industry, and look at this, and then it would be kind of frustrating when we'd see the reality that no one would change, and everything would kind of continue on the same way, more or less. And it's only been quite recently when, I think due to, really customer pressure and economic pressure that a lot of the OEMs have truly and genuinely started shifting and changing.
So what changed? Did they get scared? I mean, you're clearly taking away market share from BMW, Mercedes, these premium luxury brands, and now you're moving into the Model Y is almost the most best-selling car in a lot of places. It's a new Toyota Camry, the utilitarian, affordable vehicle for the masses.
Yeah, it's an incredible vehicle, and as you said, best-selling in many different countries and regions. So I think it's the data on what customers are choosing and the staying power of that, the fact that that's lasting year on year and growing, and not some fad. It's lasting through high prices of oil and low prices of oil. Mm-hmm. That's I think what's finally shifting is really the customer voice and the customers demanding this of other brands that they maybe are loyal to.
Right, and Bloomberg has written about the tipping point. Now we're seeing, 20% or so of new car sales in California approaching, and companies saying they're going to stop selling gasoline cars pretty soon, 2035. There's no way that doesn't happen. That happens without Tesla. And as a CTO for 15 years, you were instrumental in everything from the Roadster 6,830 batteries to other things. I think this has achieved the speed and scale that is often talked about by investor John Doerr and others. To address the climate emergency, we need things at speed and scale, and few companies, and honestly few individuals, have achieved speed and scale like you and Tesla. So what lessons do you learn from that?
Well, it was definitely difficult. That was more difficult to do both those things than we would have assumed in the beginning.
And particularly for the man you were doing it for.
He was instrumental in helping, make it happen too. But we had several unforced errors. I'm sure he'd be the first to admit, we made a lot of mistakes along the way. It was only because we started so early that we had the luxury of making some of those mistakes and not getting killed. It's a lot harder thing when you start a company and you're up against a really strong set of industry incumbents. You kind of have to execute perfectly, no missteps. But the scale is coming back to the scale. That's critical. To make an impact on sustainability, on global climate, you need scale. ideas and startup ideas are relatively more common, but we need things that can scale and do it enormously quickly to actually make a dent on the whole problem.
Right.
So, yeah.
And we need that across. And Tesla has certainly done that in the auto industry, though the brand has been damaged recently. Tesla did amazing things and was rewarded richly for it, yet the brand has also been damaged by the politics, the offensive comments of Elon Musk recently. Why did you step down from your position in 2019 and then you recently came back on the board?
Well, I mean, I love Tesla. I always have. I feel like it has some sort of place in my heart, and it probably will for the rest of my life. I love the team there. I love the mission, the products. It's awesome. Doesn't mean it's an easy place to work. It's challenging. It kind of needs to be successful, I think. Part of why I decided to leave back in 2019, and it was incredibly difficult personal decision, probably the most difficult decision business-wise in my life, was really reflecting on what I enjoy and what I'm good at. I love being an entrepreneur, and I love creating and building and being an engineer, actually being hands-on and really tinkering and building things. Certainly that was still possible to some degree at Tesla, but more and more the company needed execution at scale. It needed vehicle deliveries, it needed sales, it needed manufacturing ramp. There were people that are more passionate about that and frankly much better at it than me. And that's kind of a difficult thing to admit sometimes when you're in the midst of it, and especially if you've kind of like grown in an organization to have a position where maybe you're managing these people or alongside them, yet you kind of have to realize that wow, these people they're really passionate about doing the thing that I have to kind of force myself to do because I know it's important. So for me, that was all part of that calculus. And I also, from a topic point of view, really, I love learning. And I wanted to kind of go into an adjacent, supportive, I thought, field, where I could do something that would potentially kind of float all the ships and help electrification, help sustainability, more broadly, using kind of what I'd seen and what I learned in our struggles and some of our challenges at Tesla.
Right, and that's happened. Of course, Tesla executives have left to go to other EV companies, electric motorcycle companies. There's sort of a whole ecosystem of former Tesla people in adjacent areas. I was not really paying attention in most of high school chemistry, so could you give us a quick primer on batteries? I was high, actually, but can you give us a quick primer on batteries, like before we go forward and get into the battery part of this conversation on cathode and anode and where Redwood Materials is situating itself in that supply chain?
Well, I mean, batteries are both incredibly simple, but also incredibly complex. So to spare us all the chemical details, just think of it almost as a little electrochemical spring inside of a can. Nothing physical leaves the battery in modern day batteries. Lithium-ion batteries are sealed, they're hermetically sealed, so no air can get in, nothing can get out. And all you do is put this electric current in it and take it out of it. And the chemistry happens completely inside of that sealed can. And inside of a lithium-ion battery, what's happening is the lithium itself is just changing, its oxidation state. If we don't get too much deeper maybe than that, but there's all these other elements that are kind of supporting characters in that equation. So things like nickel, graphite, these are sort of supporting elements helping make that happen.
Right, and Redwood is positioning itself as a battery component manufacturer, though it's grabbed a lot of headlines on recycling, and so I want to start there about, according to one Stanford professor, 95% of lithium-ion batteries currently end up in landfill. Why is that, and how are you planning to change it?
Yeah, it's pretty amazing, and I think largely that happens because there's no obvious place of where people should take them. If you think about it, and you had a lithium-ion battery today, where would you take it? Most people don't know.
Stationary source. The idea is like if it's not can't get the range you want, that it could power, I don't know, something in a building where the range doesn't matter as much. But that's
Yep,
not happening.
That's still not really scaled, and where the 95% disposal is happening is even with more personal products, things like your phone or your toothbrush or your power tool or something like that. So a lot of people, are storing them up. They maybe don't want to throw it in the garbage can. For those people that feel guilty, they'll put it in a box in their garage or in a drawer somewhere.
I have a box at home that goes back to the Trio. Yeah.
Like the BlackBerry or
because I don't know what to do with them because of because of the batteries.
So that's that's an opportunity. All those batteries their materials are still in there. They're still usable as long as they get reprocessed and remanufactured.
Okay, and so you see a tremendous recycling. A battery is more complicated than a beer bottle or paper or aluminum that we know about, and so there are more components, far more materials. But as new battery chemistries are developed, how big a challenge is it for you to separate all these different materials that are, because batteries are changing so quickly?
Well, that's part of, I think, kind of the technology fun of it all is, making sure our ways to recycle and separate all these things can adapt. But we also get this weird look in history of personal electronics, because what is largely being recycled is hopefully what's worn out. So we're getting things that are these, Trios and BlackBerries and flip phones and things like that occasionally. So we have to kind of be relevant and applicable to technologies that were quite old. We still see things like nickel cadmium batteries coming in, and even lead acid batteries from huge old devices. So it kind of is a sobering reality of how you need to be quite flexible. Thinking about recycling or really any waste processing. The reality of it is a lot more messy than taking a brand new clean feedstock and then doing something precise to it.
And how much of that messiness is about changing technology, changing human behavior, and changing economics?
Most of it is really revolves around the variety of materials. When you deal with processing, especially post-consumer waste. We could talk about sort of production scrap waste and things like that. It's a different category, but post-consumer battery waste, there's just an enormous variety. So that's where the messiness comes, and an enormous variation in conditions also. I was used to working and building factories and building automation where we had, the parts presented in pristine trays and everything was perfect. And even then, still, a robot would have an enormously hard time, picking up the part that was in the perfect place, brand new, and putting it in the right place on the product and not somehow screwing it up. Here we have, a barrel full of damaged, defective, dirty materials, and trying to automate that is a whole different type of challenge.
And Redwood Materials recently announced that after a year-long pilot program, it was able to recover important metals from used batteries at a rate of more than 95%. And just note that last I checked, gasoline is 0% recycled. What are the challenges from dismantling to transporting the actual separation of those and that 95%?
Well, if I can segue for a second, what's so interesting, I think, about battery recycling, and especially as it relates to EVs, is we can imagine this future where you don't need to continually, extract and supply some chemical into a whole fleet of cars. The batteries, today might be economically 95%, but technically they're 99 or more percent reusable. All the lithium, the nickel, the copper, and cobalt, all those critical metals. So what goes into that is quite complex. We have to invent ways to, neutralize the battery, to separate out electrolyte, which is somewhat hazardous, to make sure they don't catch fire at the wrong time in the process. And then purify and separate each one of these metals from each other. It is a lot harder than notionally taking an old beer can and melting it and then stamping it into a new beer can. You can kind of look at that and very clearly say, oh, it's aluminum, it's probably going to be aluminum in a new shape. But batteries are kind of a complex mixture of chemistry and chemicals altogether.
So this really is like a dream circular economy. So how does this work? 2011, I bought a Nissan Leaf, very early EV. It was a range of kind of around 100 miles. It went down 2016 or so. Time to I think I actually gave it away to a public radio station because I didn't know what to do with it. So what would happen to that Nissan Leaf or another used EV? But you take it back to a dealer. How does the battery get in your hands?
It has a lot of different pathways. We work with auto dismantlers. We work with sometimes consumers directly. If that's relevant, we work with service centers. Parts that might be associated with an OEM if it's a warranty battery.
A car maker.
Car maker. So it's quite complex, and it's kind of the Wild West right now because people haven't really evolved this at scale.
Because it needs to be in their interest to give, you're going to have to pay them for those minerals. Why should a used car dealer turn up a car with a battery in it over to you? Because they're going to get more money doing that.
Well, and everyone's an opportunist in this chain. It's kind of human nature. So as you said, everyone wants to try and figure out what's the best value they could get for it. There aren't very many good options right now. And it's partly because transportation is difficult, and we're even having to build and kind of invent efficient, low-cost packaging to be able to get like your old Nissan Leaf battery back from maybe an auto dismantler or a wrecking yard where the battery might turn up sort of dead or as scrap. We need to get it from there to a recycling facility. So even that movement, is something that is kind of new. It's not being done at scale yet.
I'm thinking about the ink cartridges from printers. You put them in the pouch, send it back. Hopefully, that ink cartridge gets refilled. So that kind of thing for returning that product to be reused or recycled.
It's a really interesting model. I mean, it almost feels like science fiction in a way, and it feels somehow too far away for a lot of companies to worry about. But I'm confident we will electrify everything. That's where we're headed. Every passenger vehicle, every truck, every boat, I think, trains, it's all going to electrify. It really has to. And once we're in that more steady state mode where everything's already been electrified, we don't need to keep mining those materials to make the modern version of the fleet. As long as we're not growing the total fleet of cars dramatically, which I doubt we probably will, we will basically asymptote the need to mine all these materials and then go back straight down to zero.
But in the meantime, we're in this transition where there's not enough batteries coming into you. There's more EVs. Haven't been that many EVs sold. We still need raw materials to fill that gap between demand, right? And that means lithium, cobalt, nickel, copper, et cetera. They need to grow sevenfold by the next decade or so. And the social environmental impacts, child labor, all sorts of things. How can we get those materials in that transition responsibly?
Yeah, that's the complexity of this transition, is we have to do both things. We have to both support and realize that mining responsibly has to happen, or else we won't have a transition to recycle. But we also have to be planning ahead and really keeping an eye toward what does that future look like to be ready to recycle every one of those batteries. Because the worst thing we could do is mine it, go to all this destruction and trouble to mine it, refine it, build the product, and then throw it away. That's the worst pathway.
And a lot of that mining happens in the global south and indigenous lands, a lot of places, so that's real impacts.
I think with visibility and with vigilance, mining can be made sustainable, and nothing has zero impact. Unfortunately, there's just no way we figured out yet to have absolutely zero impact.
Right.
But I think as long as people are really thoughtful about that and try and have a transparent supply chain, the impact can be managed as we build the transition out.
So Redwood Materials, your company, is investing $3.5 billion in a gigantic new South Carolina manufacturing facility that will produce enough battery components to power 1 million electric cars. What percentage of the raw materials for those 1 million batteries will actually come from recycled batteries, and in what time frames?
Well, we're also building a large campus in northern Nevada. So we have sort of two main facilities, northern Nevada and South Carolina. And, as part of the materials we make for batteries, the cathode material or the foils that make up the anode, we'll target between 30 and 50% recycled material. So we blend some mined material along with the material we recycle and refine to go into a new battery. Now, there's no reason it has to be blended like that, but that's basically the sort of balance that we see is about the maximum rate that we can ramp up the feedstock of recycled material.
And so I'm thinking about a soda bottle that's like 30% recycled plastic. Will I be able to go to an EV and see that like the battery has X% recycled material? Will that be visible to customers?
I mean, there are already some regulations in Europe starting to happen where certain mandates exist around percent recycled content in things like a battery. I don't know if that'll be made visible to the consumer. The batteries generally, if it's doing its job right, it's pretty out of sight, out of mind. People don't really know where it is or what it looks like. So, it's hard to say exactly how much visibility that'll get.
And that would require mine tracing, like some kind of tracing of where the cobalt comes from, right?
Oh, it's hugely complex. There's whole businesses that need to get started around basically supply chain traceability and understanding, how to really, figure out where did the materials come from? Was it the mine that people liked or didn't like, or did it route through some country that other people don't like? It's
like
really
what people want for their coffee or things like, was it fair trade?
With the added problem that, there's a part of it that's recirculating.
Yeah.
So what part of your coffee was recycled? I don't know.
According to the Union of Concerned Scientists, the U.S. has only about 7% of the global battery recycling capacity, while China has 80%. How can the U.S. compete when China has such a head start and so much lower labor costs?
Well, China in particular, but Asia broadly, has been investing in this space for decades. Very strategically. There have been consistent, incentives and consistent support from the governments in those countries to build these industries. The one thing that we have is we're the consumers. So we're buying these cars, we're bringing them here, we're using them, and that is a really unique advantage. So there's sort of an inherent benefit, an economic benefit, an industrialization benefit to locally reprocessing these materials once they're in a region. So that's what I think is really part of the toehold, and it's part of why at Redwood we're focused on linking recycling with the material manufacturing. Mm-hmm. I think if we just attacked material manufacturing, we're competing head to head with China, and it's a brutal battle. I don't think it's the best battle to fight. If you're linking recycling of materials that are already in the region, as they are in North America or Europe or other Western countries, there I think we have a toehold and a leg up to make this economic and to make it scale.
So you're combining the recycling and the manufacturing. According to testimony you submitted to the U.S. Senate, battery minerals typically travel 50,000 miles from mine to refining to cathode production to cell manufacturing. How do we shorten that supply chain? Things are taken from the global south, they go to China, perhaps assembled in Japan, Northern Europe, come to the U.S., they move. That's just mind-boggling.
Yeah, it is almost a comical supply chain. If you drew this, it would look like like a joke. It's like the joke of a supply chain you don't want. But it's partly driven by the geology. These minerals are scattered around in their prevalence. Lithium is super prevalent in South America, and nickel in the Indonesian region, or Russia, or parts of Canada. So that's one problem, is these minerals in the mines are geographically spread all over the place. The other problem is the countries that have invested very strategically in refining and converting them, like China and other parts of Asia. So you kind of have a geologic, spreading, mixed with a centralization of refining and manufacturing, value manufacturing, that's all separated from the consumer. So by the time you have the poor consumer buying an EV, in California, like you said, this atom of lithium or nickel has traveled all the way around the world, perhaps several times, to really make it into that final product before it even drives a mile. And of course, that all has some impact that that can be somewhat negative, and it contributes to sort of the energy payback in an electric vehicle, which is still very positive. I want to make sure that's super clear. But the reason that an electric vehicle has any concept of energy payback, just like a solar panel or a wind turbine or something like that, is largely because of the embedded energy it took to mine, refine, move these materials around, and make the battery itself.
So some people are saying we should do more mining in the United States. We have stronger environmental protections. There's controversials in Nevada, where you spend a lot of your time and have a new facility elsewhere. How important is it to have more mining in the U.S.?
Well, it would be. I think personally, it would be great if we could do more of it responsibly. I think it's going to be very difficult. we don't have excellent deposits of some of these critical metals. We don't really have, excellent broad deposits of nickel or cobalt. There are some, it's not zero. But that coupled with, just a very complex and expensive, oftentimes, process to develop those mines.
So there's limits to what we can do here. We're going to need to get some of it overseas. This is all moving very quickly. I've read about iron air batteries on the horizon and solid state batteries, several car companies. Of course, we already have solid state batteries in some smartwatches and I don't know, maybe toothbrushes. Toyota claims to have made progress on this front, though I'm not sure. Toyota seems to maybe be recycling some of its announcements. What are other possible chemistries? And how close are solid-state batteries, and how could they accelerate the transition we're talking about?
Well, there are a lot of different possible, chemical couples to make new batteries, but the process to mature a battery and to really make sure it's robust and get it to scale is very, very long. There's a lot of companies that have struggled at this, and it's, I think, surprised even some of the smartest people that I know on how long that can take. So, I've learned to take new battery announcements with a little bit of a grain of salt, and frankly, we're also at a bit of a tipping point where, coming back to the beginning of our conversation, it's almost more about scale right now than it is about a slightly better newfangled battery. If I had a choice of an electric vehicle that cost maybe half as much or one that went twice as far, that's sometimes the mental test I do. And it's a no-brainer. One of these would result in dramatically, greater adoption, wider usage. The other one, moderate impact.
Right, and I think this is a real trouble in the whole climate conversation, that we're sort of have this pull toward the shiny new thing out there, rather than the more known, maybe less sexy thing that we need to do more of right now. I saw a presentation recently on solar power from outer space, can beam down without wires. I'm like, yeah, sounds cool, but what about the solar we have today that is economic? Let's do that.
Which is already the cheapest source of energy, yeah.
Rather than some shiny thing that cool thing in the future, whether it's, right. I think that's it's important to talk about, as we're talking about electrified system, we've been talking about electrifying mobility, but also batteries, have important applications in homes, on the grid scale storage. Increasingly people are getting batteries in their homes, those who are fortunate to afford them because of wildfires or in California, PG&E blowing up things or burning things. So, what advances are you seeing in batteries for stationary applications?
Well, it's vast. I mean, energy storage and I think electrochemical batteries are kind of this central technology into many sustainability products. And I don't see how we make the world sustainable without storage. And right now, batteries, lithium-ion batteries, largely are the scalable economic solution to that. Doesn't mean they'll be the only one forever. As you said, there's new technologies coming, but right now, this is kind of the core technology in grid storage at the utility scale, grid storage at the home scale, electric vehicles. It's quite pervasive when you really look across all these different products. It's part of why the bottleneck in getting enough materials to make those batteries and having access to the batteries at all is such a scary bottleneck to me. When I looked at this whole transition, I said, geez, that could derail, simultaneously a whole bunch of different industries and slow this whole transition down. So
we saw that in solar. There was solar prices been going down for decades, and then solar ticked up because of those supply constraints. It's kind of a good problem to have, but how concerned are you that this country or even your own company will overinvest heavily in a supply chain based on current lithium-ion technology, only to have newer, cheaper battery chemistries enter the market?
I mean, that one, I'm really not worried about that one. It's a question and a concern that comes up frequently. It's come up throughout the entire arc of the development at Tesla, and I think the timeline is so long on some products. Like a new EV. To conceive of it, to build a model year, to ramp it, lifetime of that product. Even if a battery technology sort of matured and changed, if solid state, promises everything it can do, it'll be wonderful, but it's relevant a product generation or two in the future. So I don't see really any risk right now that we're over-investing, I should say, in scale on some of these products. From every angle I look at it, we're dramatically under-investing. And under-investing in the supply chain, under-investing in refining, infrastructure, products. So that's what keeps me up at night. It's not an over-investment concern.
And so sounds like you're a technologist. You believe in technology, but there's also the other side of JB, the human personal side. How do you feel about the broader transition we're making? Are we going fast enough?
Well, as you said, I mean, I'm an optimist on the capabilities of what technology can do. I can see a pathway. It's kind of frustrating to both see a pathway that can solve things with known technology. We don't have to invent new physics or chemistry.
We just use what we have today.
We can do it today. But at the same time, we are not going fast enough. We're absolutely not going fast enough. And I don't think we maybe collectively realize how bad it probably will get. There's so much inertia in this system that we're meddling with.
Or how bad it is. 100 million Americans were under heat watches this week, and we're in the fog in San Francisco. It's easy to say like, oh, other people are having difficult times somewhere else, that we disassociate from it.
Yeah, so it's it's part of what lights the urgency for me is seeing and feeling the fact that this problem is so big. It touches every part of our economy. Really, it's not a dramatization to say that. I think it's something we'll be grappling with and changing and working to solve for decades. Our kids and our kids are going to be working to solve and transition around this problem.
Well, certainly there's a handful of people on this planet who've done a lot, and certainly Tesla has disrupted and changed the whole industry. Not perfect, created a lot of wealth, but certainly Detroit and Tokyo are moving a lot faster thanks to you and your work. So you've done a lot to move this acceleration. But one of the reasons it is going slow is that there is real organized, well-funded opposition. The International Energy Agency, the world's foremost authority on all things energy, recently issued a milestone forecast saying it predicts global demand for oil to be burned will peak in just 5 years. So oil companies are facing shrinking demand. You and I watched a recent advertisement by an oil company that it associates plug-in cars with chains, basically enslaved, and that driving a fossil-free car is liberty and freeing. And this was by a mobile ad that is out there, which is part of a campaign that really is going more directly at the companies that you're part of, Tesla and Redwood, saying, basically, you're enslaving us.
I almost take that as a little bit of respect. It's like, okay, we've finally gotten to them a little bit. But, unfortunately, it's going to take so long for us to reduce the entire, because really the amount of oil consumption scales with the fleet of cars, not with the new cars sold. And a lot of times we track our progress on EVs against new cars sold, and we're celebrating 20%, which is huge. It's a great milestone.
Right.
But that's 20% of the new cars going into a pool that takes perhaps 15 years to turn over. So, that's the sort of math around that, has a much bigger inertia to it. But anyway, I can't imagine what's more free, though, than driving an EV powered on solar energy at your own house. To me, that's the most free, set of products and technology you can possibly have. A cord is linking to your own roof. It's not linking to the Middle East or to even a different part of the U.S.
Right, a petro-state or something. And once you put the infrastructure, the sun literally is free once you invest in those costs. UAW negotiations are heating up around job transitions to the EVs, the so-called Batterie Belt, the region with new battery and EV factories in the southeast, right-to-work states are not welcoming to unions. Tesla has been hostile to unions. Where do you and Redwood Materials stand on worker unions?
I think it's important to figure out how we fairly transition essentially, if you look at this whole movement that has to happen, we have to transition a whole bunch of people working on various fossil fuel products and technologies and minerals, and somehow move all of them, if they're not retiring, move them into, sustainable industries and sustainable products. So, broadly, to me, that's sort of probably the most, key metric of success is where and when we can do something like that. Again, it's hard to do because their jobs aren't in the same regions, or maybe the skill sets are different.
Very different, yeah.
But I mean, that I think is what has to happen for success here. We can't just sort of, say, okay, those jobs all go away and those people won't do anything. But the other problem is we need huge amounts of jobs to do these new things. So
Right.
we end up spending a lot of time training and recruiting and hiring. And it's a blend of almost vocational training, starting even in trade schools and community colleges and universities, because we, as a country, we don't have enough of the right skills to do some of these things. I would sort of implore students out there right now to really start, try and learn a little bit more about chemistry, electrical engineering, some of these sort of different disciplines that aren't quite, maybe weren't as in vogue, weren't as trendy over the last few years.
Right. Certainly car companies don't need drive-train engineers. They need a whole different kind of person. Tesla is battling at least four racism-based lawsuits, including allegations that black workers at the company's Fremont factory are segregated into the hardest, most dangerous, and lowest paid jobs in an area of the factory that managers allegedly called the plantation. I recognize that as a board member, you won't comment on ongoing litigation, but generally, clean tech companies have less diverse workforces than even fossil fuel companies, old line auto companies. So as CEO of Redwood Materials, what are you doing about equity and inclusion?
Well, I think, basically working to create jobs and to build a company that can grow, to me is the first mission. We have to be a sustainable company that can actually provide a sustainable job for someone in the first place. That's what I worry about the majority of my time, and then making sure that we are focusing on the sustainability of our overall company. There's a lot of aspects and to try and solve with diversity and inclusion and everything else, and they're all incredibly important. But I think as a company, we need to focus to some degree, to have an impact. And for me, the focus is on sustainability first. And maybe I'm totally incorrect, but I think some of the sort of skewing on this might be that there aren't quite as many manufacturing jobs in some early clean tech companies. We're building a lot of manufacturing, very, very hands-on work that has to happen, especially with manufacturing these battery components, recycling them. So I mean, we're welcoming to any people. In fact, frankly, right now the challenge is how do we find enough employees? I think that's really a fairly key challenge as we scale this up. And I hear that same refrain from a lot of other leaders who are launching new battery factories or new EV factories.
Do you think the U.S. should open up immigration to get the people to do that sort of thing?
At the risk of making this even more political, but I mean,
a lot of employers say we need more people.
I mean, personally, I do think it's kind of crazy at some level. I think that we inadvertently restrict skilled immigration where we don't have some of these skills, yet we make it surprisingly hard to get trained people into the country and those that really want to help and can help with this. But this is pretty far afield from my area of expertise. So I kind of encounter this more at the technical immigration, technical sort of immigration
H-1B kind of. You said that you don't think anyone's moving fast enough. How can we move faster?
So much of this is driven by consumer choice. It feels both simple and hard, but I really do think that things could move faster if people understood a little bit better how to make truly sustainable choices. And if there were even, that leads to more products, it leads to driving behavior of other large companies. So I think, we need more investment, as I said before, in all these different areas, but I'm not sure I have a magic bullet for how to suddenly get more investment. I can see that it's needed, but that itself is a slow process.
Yeah, we're all clinging to the things that we know and kind of the things that got us to where we are. You started your journey by being rattled by learning about the Keeling curve, which shows the rising greenhouse gas concentrations, perhaps from Inconvenient Truth, Al Gore's film. How optimistic are you that technology can make the change, and what other kind of changes do you think we need?
Well, I'm incredibly optimistic about what the technology can do. I'm pessimistic about the speed. So
are you pessimistic about the human part of it?
Well, it's a good question. I think, yeah, maybe I guess that is one of the complexities. It's the human preferences and choices, and all the complexity of changing behavior, and as we talked about earlier, this transition will move a lot of wealth from one company to another. It moves jobs from one region to another. It has political impacts. It has government impacts. So anytime that there's some technical shift that affects people in such personal, visceral ways, it's a very complex thing to affect.
Yeah.
So I guess I am a little bit concerned about how fast all those human complexities can sort of work themselves through.
Mm-hmm. Yeah, there's lots of systems we need to change. The economy, water, food, the system between our ears is one of the most challenging systems to address. We've had far more questions than we have time for, but I'd like to invite Britt Shaw, Rebecca Elliott, Linda, and John Cheney to come in that order to the microphone over here and pose your question to JB. So Britt, Rebecca, Linda, and John. And thank JB for the race is on. Let's see if you can do it fast enough. Hi, Britt. Welcome.
Thank you. So you mentioned a little bit earlier about some of the mandates in Europe, and I know we've seen transitions toward more recycled materials coming from either a motivation by money or economics or by mandate. What is your outlook on the role of these types of mandates, the types of mandates we see in Europe for recycled battery materials, or of other policies here in the US?
Well, I think we need a combination of both. I would support both. Maybe one caveat or nuance to that is I think if we do have things like recycled percent material content, it has to be kind of thoughtful. If we had a mandate that said 100% recycled content today, this wouldn't really help things. It would actually make it worse. Then we couldn't build enough cars. They obviously couldn't be 100% recycled today. So it's tricky, and the legislators involved in this really have to understand that nuance and think it through to have that policy work. So the Inflation Reduction Act, I think made a pretty good attempt at doing this, and addressed some of that complexity and incentivizing EVs, but also forcing with a stick a little bit some of the right practices across the supply chain. But it's complex as a result.
Tough to go fast when things are complex. Rebecca, welcome.
Hi, JP. Where in the battery supply chain do you expect there to be bottlenecks over the next 5 years?
It's a good question. I think certainly in the refining of metals side of things, if I look at it, it's different with each different element, is one part I would mention. Things like lithium, I think the resource base for lithium is pretty vast. I think the world has a lot of lithium, but we have not invested and we don't have a lot of lithium processing and refining capacity. So as we sit here today, lithium refining, making it from maybe a dilute salt water that you might find in an aquifer or in a lake bed somewhere, into very high purity lithium needed for a battery, that's a big bottleneck. I think we'll also see bottlenecks at a lot of the material manufacturing stages. The supply chain to make a battery is surprisingly complex. The supply chain for many things we do is surprisingly complex, but batteries especially so. And I think we'll see bottlenecks where we take those critical metals and then make them into the kind of specialty materials that function as a battery. So, in a sort of computer analogy, it's almost like the semiconductor fabs that make things like cathode material. And this stuff is really not very sexy, which makes it kind of hard to sometimes, I think, identify with. These are somewhat non-dramatic parts that you wouldn't notice if you saw them in your car, in your electric car, but they're very critical to the function of it. So I would say refining of things like nickel and lithium, and also the manufacturing of some of the core components that go into the functional battery.
Thank you.
I think lots of people here are planning on investing in those areas just because you said that. Linda.
I hope they do.
Hi. Thank you for coming and thank you for all the work you do. Sounds great. Really exciting. My question is, could compare lithium ferrous, LFP, lithium ion batteries with lithium ion cobalt, magnesium? Because I'm not big on chemistry, but I understand a little bit. And as far in regards to sustainability and environmental impact, because I know there are two big batteries on the market right now in EVs.
Sure. Well, there's kind of there's more than that in broad scope, but there's two big categories of competing lithium-ion batteries. One is called, has a few names, but sometimes it's called LFP, lithium iron phosphate, iron, lithium. The other is generally, nickel, manganese, cobalt, NMC, various flavors like that. There's several differences, but if I kind of broadly described it, lithium iron phosphate is a little bit lower cost. It doesn't use nickel and doesn't use very much cobalt, or if any, and it's a little bit lower energy density. So, it might be a slightly heavier battery to store a given amount of energy. So in some applications, that may not matter as much. If you're putting a battery at a substation or in your basement at your house, maybe you don't care if it's 50% heavier or 30% heavier. Mm-hmm. If it's in a vehicle and you're really concerned about crashworthiness or handling or range, there the difference in mass, charge time can matter. Now, the environmental impact between the two, I think it's somewhat similar. There's a lot of different components in there, and as I said, the iron phosphate doesn't have nickel, so you maybe avoid the impact of nickel, but it does have iron and phosphates, some new chemicals that have to also be mined and refined. I think one interesting thing that maybe we don't think about enough is that we need to look at the full life cycle of these different chemistries, as they become remanufactured and recycled. Because a lot of times people compare this on sort of the first life and assume that there's no value left at the end of life. So they kind of assume that they won't be recycled. But if you do plan that they will be recycled, the nickel chemistries, in my view, kind of take a little bit more of a leap forward, because you can reuse those same elements many, many times. Therefore, the sort of mining impact of them and the upfront cost, can be moderated. But anyway, that's sort of a 10,000-foot view comparison between the two. I think they'll both coexist in the market. Very low-end, maybe entry-level vehicles that don't try and maximize range probably should be iron phosphate, LFP. Stationary batteries probably should be LFP. Whereas, longer range, passenger EVs, a little bit more, sort of higher energy density batteries would probably tend toward nickel chemistries.
Thank you.
Thank you.
John.
Hello, thank you. You've touched on this, but this is a flip side of the same coin. How would you propose, if you could, breaking the Chinese monopoly on mining, conversion, and possibly manufacturing?
I mean, I did sort of touch on it a little bit, but it seems self-serving, but I think that actually recycling and remanufacturing is the way to begin to break that monopoly. It's the first chance where we basically can kind of have a discontinuity in that. Otherwise, the scale just increases, the economics, the centralization just increases. But the difference is that, they're mining it, refining it, we're buying it, and then we have it. So, it sounds ridiculously simple, but that's the truth of it. And we sort of don't realize maybe the power of that and sort of what that means as we sort of go through that cycle. China could monopolize, all of the mining and refining of this completely, and we'd still be completely independent of all of that by the time we built out and converted our whole fleet to EVs, as long as we invest also in reprocessing and recycling. So
we could have a bunch of EVs and then eventually when we get to scale, just keep recycling the materials for those batteries and not have to do a lot of importing, mining, new mining, et cetera.
I mean, it's the ultimate energy security. If you have a fleet of EVs that are powered by sustainable energy, in a region, you don't need sort of this massive, transport of chemicals that bring energy in or out of that. It's supplied by, solar or wind or whatever it may be. And those materials can be reprocessed. We can do it today. It'll be even cheaper and easier to do when scale is 1,000x what it is today. But again, it's quite tricky, going from here to there. We need to do this dance and support, and make sure we don't hit a bottleneck where, things maybe get cut off or there's some huge dispute that causes even more, pain or where the leverage is applied. So anyway.
Or prices spike. We have to wrap it up. Thank you, JB, for joining us on Climate One and sharing your insight and stories, and really one of the true climate heroes for your passion for all that you've disrupted and done. On Climate One today, we've been discussing building a more sustainable battery supply chain with JB Straubel, CEO of Redwood Materials. Special thanks to ClimateWorks Foundation for underwriting this program, this episode. I'd like to also give a shout out to the Climate One and Commonwealth Club teams for making this happen. That is Adam, Dan, Alex, Megan, Billy, Brad, Jenny, Wency, and Ben. They are awesome. Let's give them a round of applause. They get to sit up here. Podcasts of this and other Climate One shows are available wherever you get your pods. Talking about climate can be exciting and sometimes difficult. We do it all here. Remember to rate and review if you download our pods. And then thanks for joining us. We'll see you next time, everybody, both here in the room and online. Thank you, everyone.
Thank you for watching. If you liked this video, I'd appreciate it if you could show your support by hitting the like button and subscribing to our channel. You'll never miss out on my latest material, chats, or intriguing features if you subscribe. I am dedicated to providing you with useful information as well as funny moments from the world of finance. So, subscribe, keep in touch and informed with Manatech.